we're going to look at the chain rule. The chain rule, in my opinion, is probably the coolest derivative rule that we can take. It incorporates so many different aspects, and it basically can handle every one of the other rules that we've looked at, whether it be power, product, or quotient rule, within itself. The chain rule is really neat. It's basically taking the derivative of a function within a function. And throughout this video, you're going to get to see how that happens. But again, all of these rules follow very specific plans, or not really plans, but just patterns and so forth. So when I want to take f prime of x of a function that is going to need the chain rule derivative, I have this function h of x, that's my outside function. I have to take the derivative of this outside function before I can attack g of x. Now, once I take the derivative of that outside function, I can then multiply by the derivative of that inside function. And that right there is our basic chain rule principle. So let's check out a couple of examples. Let's see how it works. And hopefully by the end of this video, you guys will feel like you have mastered the chain rule. So I'm going to start off with this one. This one's fairly easy. When I look at this, to me, my outside function is a giant chain rule problem, right? So this outside function is 3 times the inside piece, and then that outside function is raised to the 8th power. So when I take f prime of x, I need to get that outside function derived first. So we're going to bring the 8 down, just a simple power rule, so 8 times 3. The inside is going to stay the same, and then my power is going to decrease by 1. Times, and now we can take the derivative of that inside part, so times 4. Because simply it's just a power rule, 4x drops down to 4, 1 disappears. And so now what we can do is we can simplify. Since everything's multiplying, my coefficients here will multiply, and I will simplify my problem so that I'll have f prime of x equals, well, 4 times 8 is 32. 32 times 3 is 96 times 4x plus 1 to the 7th power. And that's our derivative. So that's a basic chain rule problem. Again, take the derivative of the outside portion first, and then multiply it by the derivative of that inside piece. Okay, let's look at another one. So here we're going to start incorporating a trigonometric function within our derivative. So again, my outside function here is sine sine, and then my inside piece is 3x to the 4th. All right. So when I want to find g prime of x, the derivative of sine is cosine, and 3x to the 4th will stay the same. And now we can multiply by the inside derivative, which is just a power rule. 4 will come down, multiplying to the 3. And then the 4 will decrease by 1, giving me, it's 12, not a 4, 12x to the 3rd power. Go ahead and clean it up like good mathematicians do. We have g prime of x equals 12x cubed cosine of 3x to the 4th power. So again, still chain rule, not too difficult. Taking the derivative of that outside piece and then multiplying by the derivative of the inside function. All right, let's look at another one. So let's look at this example. We have m of x equals the natural log of 3x squared. If I wanted to take the derivative of this particular function, I need to first be very comfortable in knowing that the derivative of ln of x is 1 over x. So just kind of do some chicken scratch over here. If I had a whole nother problem, if I had n of x equals the natural, if I had n of x equals the natural log of x, and I wanted to find the derivative of m prime, that's going to be 1 over x, okay? So following that same idea, when I take the derivative of m of x, we wind up with 1 over 3x squared. So I have now taken the derivative of the outside piece times the derivative of that inside piece. Go ahead and be a good mathematician and simplify. That gives me 6x over 3x squared. Simplify that even more, and we wind up with 2 over x. Not too bad, right? Fairly simple. Hopefully these chain rule problems are definitely looking a lot easier. I got one more for you. This one is just simply an e function. And so, again, let's do some chicken scratch over here. This is probably the hardest derivative that you will ever take is e to the x. If I had, let's say, t of x equals e to the x, it's really hard to memorize. I'm sorry, this is being a math joke. It's not that funny. T prime of x, anytime I take the derivative of e to the x, it's e to the x. It's the same thing. So that's just, again, that one in the natural log of x, those are just things that we really need to memorize. So following this back over with n of x over here, e is my outside function. I need to take the derivative of e first. So n prime of x equals e to the sine of 5x squared. While it doesn't look like we've done anything, we have taken the derivative. E is its own derivative, therefore we are good. Now I must take the derivative of sine of x. So that gives me cosine, that inside piece stays the same, times the derivative of now that inside piece, which is 10x. So go ahead and simplify this whole problem here. That gives me 10x e to the sine of 5x squared times cosine of 5x squared. And that is n prime of x. And that is the chain rule. So thanks for checking out the video. I hope it helped. See y'all next time.